Hi. If you're calculating retention using count distinct user underscore ID, you're probably not calculating retention. You're calculating something else, and your business decisions might be based on the wrong metric. Today, I'll show you the most common retention mistake analysts make in SQL, why it happens, and how to fix it properly using cohorts. Most retention mistakes have nothing to do with SQL syntax. They come from incorrect thinking. Let's imagine I'm a product analyst. We have a users table, an events table, and the business asks, are users coming back after signing up? Simple question, very commonly answered incorrectly. Before writing any SQL, we need to understand the structure. I generated this dataset specialna for this demo. It's not textbook data. It's not production data. Why? Because I want full control over user behavior to clearly show typical analytical mistakes. Users, table columns, user underscore ID signup underscore date. The signup date defines our cohort. I generated 1,000 users across 30 days, so now we already have 30 daily cohorts. Events, table. Each row equals one user action. It could be click, view, purchase. For simplicity, we use just one event type, activity. Important detail, only approximately 70% of users perform at least one event after sign-up events occur within 30 days. That's very realistic product behavior. Not everyone activates. Here's what many analysts do. They group events by week, count distinct user, underscore ID, call it retention. Looks correct, but it's not retention. Why? Because this query ignores sign-up date, ignores cohorts, ignores users who never came back. It's just counting active users per calendar week. Retention is behavior relative to sign-up moment. Big difference. Also, users who never return disappear from the result, so your retention is artificially inflated, and that's dangerous. Now let's fix it. Step 1. Assign each user to a cohort using signup underscore date. Step 2. Measure activity by week after signup. Step 3. Critical. Use a left join. Why? Because we must include users who never returned. Retention is always returned users divided by total users in the cohort. If you lose users in the denominator, your metric is broken. The real difference. Wrong query. Counts active users grouped by calendar time, no cohort logic. Correct query. Defines cohorts tracks. Activity relative to sign-up groups by cohort, week, and activity week. That's real retention. Now we create a classic retention matrix. Rows to sign-up cohorts, columns to weeks after registration. This is the format every product team uses. How to interpret it. Example. Cohort, December 29th, 2024. Week 0 to 10 users. Week 3 to 28 users. Week 4 to small decline. Another cohort, January 5th, 2025. Week 0 to 22 users. Week 2 to 43 users. If later weeks stay strong, it usually means users found value. If retention drops fast, you likely have activation or product market fit issues. Cohort trends. On the heat map, we can see later January cohorts show higher retention. That could mean better onboarding, improved product features, stronger activation strategy. Cohort analysis lets you connect metrics to product decisions. Wrap up today. We identified a common retention mistake, fixed the logic built, correct cohort, SQL, analyzed retention trends. In the next videos, we'll explore more advanced retention scenarios. The full dataset, scripts, and extra exercises are in the practical SQL repository. Link in the description. If you're serious about product analytics and SQL, subscribe. See you in the next one.